All right, settle in for a deep dive that's going to equip you with some serious insider knowledge.
Mm-hmm.
Have you ever found yourself watching a master woodworker, maybe, expertly crafting a beautiful piece, and realized they're speaking a language all their own,
Oh, yeah.
filled with terms like burl or bow, jig, or collet?
Definitely.
Even if you're a seasoned enthusiast, that jargon can sometimes make you feel like you're missing a piece of the puzzle.
It really can.
Well, today, we're giving you that missing piece. We're cutting through the specialized vocabulary to give you a shortcut to being truly well-informed in the fascinating world of woodworking.
That's spot on. Our mission for this deep dive is to unpack the most important nuggets of knowledge from, well, a comprehensive glossary of wood words.
Okay.
We're not just going to tell you what these terms mean, but crucially, why they matter.
Right.
Why they matter to the craft itself, to ensuring your safety in the shop, and to achieving truly incredible results in your projects. You'll walk away able to confidently talk about everything from the very anatomy of wood, the basics, to the intricate details of joinery, and even the subtle but significant differences in lumber grading.
And what truly fascinates me about learning this vocabulary is how it completely transforms your understanding of the craft itself.
Mm-hmm.
Mastering this isn't just about sounding smart. It's about truly appreciating the precision, the artistry, and the hidden complexities that go into creating something beautiful from wood.
Absolutely. It gives you a deeper appreciation.
So let's unpack this. Are you ready to sound and maybe even think like a pro?
Let's do it.
Every great woodworking project, of course, begins with the very material itself. Wood.
The foundation.
Exactly. We often hear hardwood and softwood used, maybe interchangeably, or just assumed to mean how tough they feel. But what do those terms really mean, beyond just a generic sense of hardness?
That's a fundamental distinction, and it's quite fascinating because the common perception can be a bit misleading. Hardwood actually comes from broadleaf trees, botanically known as angiosperms.
Angiosperms, right.
Think of classic species like oak, walnut, cherry, maple, mahogany. These trees are typically deciduous, meaning they shed their leaves annually,
Like most shade trees.
Right. And they produce seeds encased in fruits or nuts. So your familiar shade trees or fruit trees are generally hardwoods.
Got it.
Softwood, on the other hand, comes from needle-leaf trees, which are conifers or gymnosperms.
Conifers, yeah. Pine trees, fir.
Exactly. Trees like spruce, pine, or fir, which often retain their needles year-round and produce seeds encased in cones, like a pine cone.
So if I understand correctly, it's more about the botanical classification of the tree, its reproductive strategy, how it makes seeds, rather than the literal hardness of the wood.
Precisely.
Because I know balsa wood is incredibly soft, yet it's often cited as a hardwood.
Precisely. That's a common and really important misconception to clear up. The core belief that hard inherently means dense and soft means light isn't always true.
Yep.
For example, balsa, famous for being incredibly light and soft to the touch, is botanically classified as a hardwood because it comes from a broadleaf tree.
Oh, okay.
Conversely, some softwoods like Douglas fir or ponderosa pine can be remarkably strong and, well, they certainly aren't soft in the way you might imagine.
Yeah, definitely not soft like balsa.
Not at all. What's truly relevant for you as a woodworker is how these tree types influence the wood's structure. Hardwoods often have a more complex sort of interlocking grain, making them denser and more durable, but sometimes harder to work, often requiring sharper tools.
Okay.
Softwoods, with a simpler, straighter grain, are generally easier to cut and shape, but they can be more prone to dents and dings.
Makes sense. So beyond the type of tree, wood has its own internal geography, right? Like if you cut into a tree, you see different rings and colors. How do terms like heartwood or grain direction give us insight into the material we're actually working with?
You've hit on it. When you look at a cross-section of a tree trunk, you'll immediately see those distinct visual differences. Heartwood is the darker, mature wood found right at the very center of the tree. It's essentially the non-living core that provides structural support and often possesses greater durability and resistance to decay compared to the lighter sapwood surrounding it.
Sapwood being the lighter part closer to the bark.
Exactly. It's the living part, transporting water and nutrients. Then, fundamentally, grain direction refers to how the elongated fibers or cells of the wood are oriented.
Okay.
These fibers essentially run along the length of the tree, and their direction is absolutely crucial for how wood behaves when it's cut, shaped, or even how it accepts a finish.
Crucial how?
Well, understanding grain direction is paramount for preventing tear out, when fibers rip out instead of cutting cleanly. It helps ensure smooth cuts and even predict how your project will respond over time to changes in humidity.
Ah, wood movement.
Exactly. Cutting against the grain can lead to splintering right now, but ignoring it in your design can lead to wood movement and potentially joint failure later on.
Got it. And what about the visual characteristics we might see on the surface of a board? I've heard terms like face grain and edge grain tossed around, but also more unique patterns that woodworkers seem to go crazy for.
You'll definitely encounter those as soon as you start looking at lumber. Face grain is the pattern created by the growth rings on the broadest surface of a board, what you typically see on top of a table or the front of a cabinet door.
The pretty side.
Often, yeah. This is often the most visually appealing surface. Edge grain, on the other hand, is where the growth rings are more perpendicular, or at least 45 degrees or more, to the board's surface. Think of the narrow side of a board, or the cutting surface of a butcher block.
Right, more lines.
More parallel lines, usually. Then there's end grain, which is the cross-section of the wood fibers, showing the growth rings as concentric circles. End grain is much more absorbent and typically harder to sand and finish smoothly.
Okay.
Beyond these basic orientations, wood offers incredible natural beauty in its patterns, often referred to collectively as figure.
Figure, right.
These are the unique patterns and designs that appear in the wood grain due to various factors like the way the tree grew or maybe how it was sawn. For instance, bird's eye refers to small circular indentations on wood surfaces caused by unique fiber formations that look like tiny eyes.
I've seen that in maple. It's beautiful.
It really is. And a burl is a swirling, twisted figure in the grain, often from growths on the tree's exterior or root system, usually caused by some kind of stress or injury to the tree.
Like those big round growths you see on trees sometimes.
Exactly. These figured woods, like bird's eye maple or burl walnut, are often highly prized for their aesthetic beauty and can fetch premium prices because they're so distinctive and rare. They can turn a simple piece into a true work of art.
It's incredible how much character can come out of a tree. Now, speaking of how a tree is sawn, I've heard terms like quarter sawn or flat sawn. How does the way a log is cut into boards influence the grain appearance and, maybe more importantly, the wood's stability?
That's a critical point because it impacts both the look and the long-term performance of the wood. The most common method is flat sawn, sometimes called plain sawn. Here, the log is cut straight through, tangential to the growth rings.
Tangential, okay.
This produces that distinctive cathedral arch pattern on the face grain you often see on oak, for example. It's the most efficient way to cut a log, yielding wider boards. But flat sawn lumber is often less stable and more prone to cupping or warping because the growth rings are running more or less parallel to the board's face.
Ah, so that movement we talked about.
Exactly. Then you have quarter sawn lumber. This involves cutting the log into quarters first, and then slicing boards perpendicular or radially to the growth rings.
Okay.
This results in a much straighter, often striked or flecked grain pattern. Think of the raisin oak. And crucially, it makes a significantly more stable board that is less prone to warping, cupping, or twisting with changes in humidity.
So better for things that need to stay flat.
Often, yes. It's frequently used for furniture components where stability is paramount, like drawer sides or frame and panel doors.
Interesting. Is there anything else?
There's also rift sawn, which is less common. Here, the boards are cut at roughly a 30 to 60 degree angle to the growth rings. This yields an even straighter, more uniform linear grain than quarter sawn, but it's less efficient to produce and therefore generally more expensive.
So flat sawn, quarter sawn, rift sawn, different looks, different stability.
Precisely. Each method produces different characteristics, influencing everything from how the wood moves to how it takes to finish.
That's a fantastic insight. Okay, before we even get to cutting a single piece, the moisture content of wood is a huge deal for woodworkers.
Oh, absolutely critical.
What's the difference between green wood, air-dried, and kiln-dried lumber, and why does that matter so much? Because I've heard horror stories about projects falling apart due to wood movement.
You have, and for good reason. This is absolutely critical for wood stability and for the longevity of any project you build. Misjudging moisture content is a common source of frustration and, well, project failure.
Okay, so what's green wood?
Green wood is freshly cut and has a very high moisture content. It's essentially wood straight from the tree, full of sap.
Right.
It's often preferred by wood turners because its high moisture makes it more pliable and easier to work with on a lathe, allowing for some interesting forms as it dries. But you wouldn't build furniture with it.
No, definitely not. Okay, so air dried.
Air-dried lumber is wood that has been dried naturally by stacking it in open air with spacers between the boards, allowing moisture to evaporate slowly and evenly.
How long does that take?
It can take a long time.
Hmm.
A common rule of thumb is 1 year per inch of board thickness. So a 2-inch thick board could literally take 2 years to air dry properly.
Wow.
In most regions, air-dried wood will typically settle at a moisture content somewhere between 12 and 20%, depending heavily on the local climate and humidity.
And kiln dried is a faster, more controlled process, I imagine. And what kind of problems are we really trying to avoid by getting this moisture thing right?
Correct. Kiln-dried lumber is dried in a controlled chamber called a kiln. Inside, the airflow, humidity, and temperature are precisely regulated.
Like a big oven? Sort of.
Sort of, but with humidity control too. This accelerates the process significantly, reducing moisture content in just days or weeks rather than months or years. Kiln drying typically reduces moisture to desired levels, usually 6–10% for hardwoods and high-grade softwoods intended for indoor furniture.
And construction lumber.
Construction lumber is often dried to maybe 12–20%. Knowing the exact moisture content, which is the total amount of water in a piece of wood expressed as a percentage of the wood's oven-dry weight, is key. This is often determined with a specialized tool called a moisture meter.
Right, those things with the pins you stick in the wood.
Exactly, or pinless ones that read capacitance. Now, the problems you're avoiding. If your wood isn't at the right moisture content for your environment, meaning the moisture content that matches the average humidity of where your finished project will live.
So like inside your heated house versus an unheated shed?
Precisely. You risk significant movement. Warping, bowing, checking, or cracking after your project is built. Imagine building a beautiful tabletop, only for it to suddenly develop a nasty curve. That's often a bow, where the ends of a board curve up or down along its length.
Okay.
Or perhaps it develops a cup, which is a concave or convex curve across the width of the board.
Like a shallow U-shape.
Right. Even worse, you might get a twist, which is a distortion along the length of a board where the ends are no longer in the same plane, like a propeller.
Oh yeah, that's bad.
All these are forms of warp, which is just a general term for any distortion of a board from its true flat plane. You might also see checks, which are splits running along the grain, often occurring in the end grain as it dries faster, or even outright splits. These defects can lead to joint failure or visible flaws, so getting moisture content right is absolutely non-negotiable for project longevity.
Wow. Okay, lesson learned. Pay attention to moisture. Now, once the wood is dried, how is it measured and graded for sale? I've heard terms like board foot and FAS, but they seem a bit of a mystery for anyone just starting out.
Yeah, it can be confusing, especially if you're used to buying lumber at a big box store where everything's in standard sizes. What's fascinating here is how the industry measures and grades lumber, especially hardwoods, which often sell in random widths and lengths.
Random widths and lengths.
Yeah, unlike, say, a 2x4, which is always the same nominal size. Hardwood comes as the tree yielded it, more or less. The standard unit for volume is the board foot.
Board foot, okay.
It calculates the total volume of wood. Essentially, one board foot is a piece that measures 1 inch thick by 12 inches wide by 12 inches long, or its volumetric equivalent.
So like 144 cubic inches.
Exactly. You calculate it by multiplying the thickness in inches by the width in inches by the length in feet, then dividing the whole thing by 12.
Thickness, width, and X length 12. Yes.
Right. So when you buy hardwood, you're paying for the actual volume of usable material, not just linear feet, which can be a surprise for new buyers used to buying pine boards.
And the grading. What does FAS stand for, and why is that so important for a professional woodworker?
FAS is an abbreviation for firsts and seconds, and it represents the best, highest quality boards cut from a log according to NHLA grading rules, the National Hardwood Lumber Association.
Firsts and seconds, okay, the top tier.
Pretty much. To qualify as an FAS board, it must meet certain minimum size requirements, generally at least 6 inches wide by 8 feet long. And, crucially, it has to yield a minimum of 83% clear cuttings.
Clear cuttings, meaning free of defects.
Exactly. Areas free of knots, splits, excessive warp, and other defects. And these clear areas themselves have to be of a certain minimum size, like 4 inches by 5 feet or 3 inches by 7 feet.
So you get large, usable, defect-free sections.
That's the idea. For a professional, buying FAS means significantly less waste and faster processing because you're spending less time cutting around defects. It directly impacts project timelines and profitability. It's truly the premium stuff, ideal for furniture, where large, clear panels are needed.
So that's the premium stuff, but what about how it's actually processed for sale? Because wood comes in different states of finish, right?
Yeah.
Rough from the saw or already smoothed out.
Exactly. It's not always ready to use right off the truck.
Yeah.
We distinguish between rough-on boards, which, well, they retain their rough, often splintery surfaces from the initial milling at the sawmill. No planing, no re-ripping.
Raw and unrefined.
Right. This is often what you find directly from a smaller sawmill. Then we have surface lumber. S2S means surfaced on two sides.
S2S. Okay.
These boards have been planed on both faces to a final, consistent thickness after milling and drying. For example, a nominal 44 board that's pronounced 4/4, meaning 1 inch thick nominally,
4/4, got it.
often becomes maybe 13, 16, or 7/8 of an inch actual thickness after surfacing. You're getting a consistent thickness, but the edges might still be rough or uneven.
Okay. And S3S.
S3S means surfaced on 3 sides. These boards are planed on both faces and then straight line ripped on one edge to create a true straight reference edge.
That's handy for the table saw.
Incredibly useful. Most hardwood sold at lumber yards is S2S or S3S. And finally, S4S means surfaced on 4 sides.
S4S, all 4.
Yep. These boards are planed on both faces and then ripped on both edges to be parallel, making them completely square and consistent in dimensions. This process produces dimensional lumber like a 1x6 or 2x4, which is common for construction lumber and some hardwoods you might find in home centers.
Ready to go.
Pretty much. This level of surfacing makes the wood ready for immediate use in many applications, but always remember that the nominal size, the name like 1x6, often differs significantly from the actual dimensions after surfacing. A 1x6 is usually closer to 34 inch by 12 inches.
So we've got the wood understood, from its core characteristics to its moisture content and how it's prepared. Now, once it's ready, how do we actually join pieces together? Let's talk adhesives. What are the key types and their properties, beyond just calling it glue? Because I'm sure there's a specific glue for every situation.
You're right, calling it glue is just the starting point. There's a whole world of adhesives out there. When we talk about adhesive, we're generally talking about glue, but there are specialized types for different purposes.
Yeah.
A common one you might use for specific jobs is contact adhesive or contact cement.
Contact cement, right, for laminates.
Exactly. It's a thin, often rubber-based glue used most often for bonding things like plastic laminate to a substrate, like particle board for a countertop. The unique property here is that you apply it to both mating surfaces.
Both sides.
Both sides. Let it dry until it's just tacky to the touch, and then they bond instantly and strongly on contact.
No second chance.
None. You don't get a second chance to reposition it, which makes precise placement absolutely critical.
Okay. What's the main stuff woodworkers use day to day?
Well, the workhorse of most woodworking shops is PVA glue, or polyvinyl acetate.
PVA, yellow glue, white glue.
Exactly. This is your common yellow or white woodworking glue. Yellow glue, technically an aliphatic resin glue, generally offers a stronger initial tack. It grabs faster and it sands more easily than white glue once dry. White PVA glue is often used for general purpose bonding, crafts, that sort of thing.
And they're water-based.
Both are water-based, generally non-toxic, easy cleanup with water, and offer decent open times. For outdoor projects or things needing more water resistance, you'd reach for a water-resistant PVA glue, like Type Bond 2, or even better, Type Bond 3, which offers superior water resistance, often rated as waterproof.
Okay. What about super strong bonds or filling gaps?
For stronger bonds or specific applications like oily woods or maybe filling small gaps, you might use polyurethane glue. Think Gorilla Glue. That's a common brand.
Right, the stuff that foams up.
Exactly. This glue actually requires moisture to cure, so you often need to slightly mist one surface with water. It expands as it cures, foaming into the joint, which can be useful for filling small gaps, but it can also be quite messy if you're not careful with squeeze out. It offers excellent water resistance, often waterproof.
And epoxy.
Epoxy is another strong contender. It's a 2-part adhesive consisting of a resin and a hardener that you mix together just before application.
2 tubes you mix.
Usually, yeah.
Yeah.
It offers incredible strength, fantastic gap-filling properties, and excellent water resistance, making it ideal for structural repairs, boat building, or bonding to similar materials like wood to metal. Its open time can vary wildly from 5-minute quick-set epoxies to much longer cure structural epoxies with hours of working time, depending on the formulation.
And what about those quick fixes or for patterns if I want to temporarily attach a template to my wood so I can cut around it? I wouldn't want a permanent bond there.
Right. For quick fixes, especially for small repairs or attaching molding quickly where clamping is tough, CA glue or cyanoacrylic glue is incredibly useful.
Super glue.
Basically, yeah, it's a super glue that bonds almost instantly, especially with an activator spray. For temporary template attachment, you'd use a spray mount adhesive,
Spray adhesive.
often an artist's variety, maybe like 3M Super 77, or a repositionable type. The trick, as you said, is to always spray the adhesive on the pattern or template, not the wood itself,
Why is that?
so that it can be peeled away cleanly later without leaving sticky residue or potentially damaging the wood surface fibers. It's designed for temporary, sometimes repositionable bonds.
Got it. Any other glues we should know?
Well, for fine furniture or historic reproductions, sometimes hide glue is used.
Hide glue, like from animals.
Traditionally, yes, it's made from animal collagen. It comes in liquid form, ready to use, or granular form, which you mix with water and heat in a glue pot. It offers a unique property. It's reversible with heat and moisture.
Reverse.
Yeah, you can essentially take the joint apart later without damaging the wood, which is invaluable for certain restoration work or instrument making. It also has a long open time and allows for some creep, which can be good in certain situations.
Wow, that's a lot more nuanced than I expected from just glue. Now, beyond the type, there's clearly a science to how long you have to work with it and how long you have to wait. What are open time, set time, and dry time? Because misjudging these could be disastrous, right?
Oh, absolutely. These timings are crucial for successful glue-ups in woodworking, and misjudging them can indeed lead to weak joints, joint failure, or just a botched assembly.
Okay, so open time.
Open time, sometimes called working time, is the duration after you spread the glue before it becomes unworkable or loses its ability to create a strong bond. Essentially, how long you have to get the parts together and clamped.
And that varies.
Hugely. Standard yellow PVA glue typically gives you maybe 5 to 10 minutes. Polyurethane can offer around 20 minutes. Epoxies, as we said, can range wildly from just 5 minutes for quick set types to a full 12 hours or more for slow cure structural ones.
So you need to know your glue.
You absolutely need to know your glue and plan your assembly. If you exceed the open time, you'll likely get a weak or failed bond because the glue starts to skin over or partially cure before the parts are properly clamped together. Some manufacturers even make glues with specifically extended open times for larger or more complex assemblies where you need more time to position multiple parts.
And then after that, once I've got my pieces clamped, how long until I can unclamp my project without it falling apart? And then how long until it's truly strong?
Right. 2 more stages. The first is set time. That's the period required for the glue to dry or cure enough for the clamps to be removed without the joint failing under its own weight or slight stress.
So strong enough to handle carefully.
Exactly. Again, it varies. Yellow glue typically sets in 30 to 60 minutes. Water-resistant yellow glue might need about an hour. Polyurethane glue also generally sets in about an hour, maybe a bit longer. Quick-set glues are available, like CA glue, for projects needing faster adhesion, like assembling moldings that are difficult to clamp for extended periods.
Okay, and the final stage.
That's dry time, or cure time. This is the total time required for the glue to completely dry and achieve its full maximum strength and bond integrity. This can be anywhere from a few hours for some PVAs, or it might take up to 24 hours or even longer depending on the glue type, the wood type, the joint type, ambient humidity, and temperature.
So don't stress the joint too early.
Definitely not. Knowing these times is essential for ensuring the integrity and longevity of your joints. Rushing this step, taking clamps off too soon, or putting stress on a joint before full cure is a classic beginner mistake that leads to disappointment down the road.
Are there any tricks to getting a perfect glue joint, especially when you have multiple pieces coming together or when you're dealing with that messy excess glue?
Definitely. A fundamental practice, and one that saves countless headaches, is to always dry fit your project first.
Dry fit, just put it together without glue.
Exactly. Assemble it completely without glue or fasteners to check the accuracy of your joinery, make sure everything fits perfectly, and to determine your final assembly sequence. It allows you to anticipate any issues, figure out your clamping strategy before the glue is setting and the clock is ticking.
Smart. What about the glue that squeezes out?
Squeeze out. When you apply glue and clamp your parts, you'll likely see a small bead of glue pushed out from the joint line under clamping pressure. This is generally a good sign. It means you used enough glue and applied sufficient pressure.
But it looks messy.
It can. It's generally best to remove this fairly quickly. You can wipe it away immediately with a damp cloth, being careful not to spread it too much and create a larger mess that can interfere with finishing later. Or an alternative method many prefer is to let it skin over slightly, maybe for 15–30 minutes depending on the glue. Then you can carefully scrape it off with a sharp chisel or a scraper blade after it firms up like rubber, but before it fully dries and hardens. This often leaves a cleaner surface.
Okay. And tricky clamping, like on angled surfaces.
Yeah, for tricky clamping situations, especially when you don't have a flat, parallel surface to clamp against, you can use clamp blocks. These are often just scrap pieces of wood, maybe wedge-shaped or custom-shaped, that are temporarily spot-glued or even just held in place to provide a flat, stable surface for your clamp jaws. They make it much easier to apply even pressure and achieve a tight joint on awkward shapes.
And for structural integrity and alignment, I've heard woodworkers talk about biscuits and a biscuit joiner. What exactly are those and how do they work together?
Right. Biscuits are very common. Biscuits are a common name for football-shaped wooden plates. They're made from compressed beech wood.
Compressed wood?
Yeah, compressed beech. They're widely used in joinery, primarily to strengthen and, maybe more importantly, align glue joints, especially in edge-gluing panels or building cabinet carcasses. They fit into slots cut by a biscuit joiner.
Which is that tool that looks kind of like an angle grinder.
It does resemble one, but it's quite different in function. It features a precision fence and base that work together to align a small, retractable circular blade. When you plunge the tool into the edge or face of the wood, the blade cuts half of the crescent-shaped slot in one mating piece. Then you repeat the plunge on the other mating piece, ensuring the slots line up.
And the biscuit goes in the slots.
Exactly. The biscuit then fits snugly into these slots. The brilliance of biscuits is twofold. First, they significantly increase the glue surface area within a joint, which improves holding power. And second, and crucially for assembly, because they're made of compressed wood, they expand slightly when they absorb moisture from the glue. This swelling action helps to lock the joint together and hold it in perfect alignment during clamping, preventing the pieces from sliding around as you tighten the clamps.
Ah, that's clever. It keeps things lined up.
Precisely. They come in standard sizes like #0 the smallest, #10, and #20 the largest, each designed for different material thicknesses and joint strengths.
So we've got our wood prepped and we understand how to glue it up. Now let's move into the workshop itself and talk about the big machines, starting with the table saw, which is often considered the heart of a woodworking shop.
It often is, yeah.
What are the key parts that make it work and, equally important, keep us safe from what can be a very dangerous tool?
The table saw is indeed central to many workshops, and understanding its components is vital for both effective use and, critically, for safety. At its core is the arbor. That's the threaded shaft where the saw blade mounts, and is held securely in place with a washer and a nut. This arbor rides on bearings and is rotated by drive belts connected to the motor, spinning the blade at very high speeds. Most 10-inch table saws, the common size, have a 58-inch diameter arbor, which is a standard size for most 10-inch blades.
Okay. And for safety, what about the parts that protect us from that spinning blade or from the wood being thrown back at us? That sounds terrifying.
It can be. Safety is absolutely paramount when operating a table saw, and sadly, many accidents are preventable if safety features are used correctly. The blade guard is a crucial component.
The plastic thing over the blade.
Often plastic, sometimes metal. It's a shroud that covers the blade, directly preventing your hands from accidentally contacting the spinning blade from above. It also helps stop small cutoffs from being thrown towards the operator, and it often incorporates a dust collection port.
Okay. And kickback, what stops that?
Right. In conjunction with the guard system, you often have anti-kickback pawls. Yeah, pawls. These are spring-loaded metal plates, usually with sharp sawtooth edges, often integrated into the blade guard assembly or the splitter. They are a lifesaver, quite literally. They're designed to ride on top of the wood and dig into it instantly in the event of kickback.
Kickback being when the wood shoots back?
Exactly. Kickback is a dangerous mishap where the spinning blade, usually the rising teeth at the back of the blade, catches a workpiece and suddenly throws it violently back towards the operator at high speed. The pawls physically dig into the wood, preventing it from being propelled towards you, significantly reducing the risk of serious injury.
Wow. Okay, so pawls are important. What prevents the wood from pinching the blade in the first place, which I imagine could also lead to kickback and other problems, and how is the whole blade assembly supported?
Good question. That's the function of the splitter, or often now a riving knife. A splitter is a thin vertical plate positioned directly behind the blade. Its purpose is to keep the kerf, which is the slot produced by the saw blade as it cuts through the material, from closing up behind the blade and pinching it during a cut.
Pinching causes problems.
Oh yeah. Pinching can indeed cause kickback, burning of the wood, and can bind the blade, potentially stalling the motor, or worse. A riving knife is a more advanced type of splitter that's attached to the arbor mechanism, so it moves up and down with the blade and stays close to it, providing constant protection regardless of blade height. Most modern saws use riving knives.
Okay. And the support structure.
The table saw's entire drive mechanism, the motor, arbor, belts, and the assembly that controls the blade's tilt and elevation are supported by the trunnions.
Trunnions. Sounds heavy duty.
They usually are, typically a robust cast iron assembly. On a cabinet saw, the heavier duty type, these trunnions mount directly to the cabinet body itself, providing a very stable vibration dampening platform. On a contractor saw or hybrid saw, they often mount in the underside of the table, which can be somewhat less stable and harder to align perfectly.
And that removable plate around the blade, that's more than just a cover, right? Especially when you're talking about precision or preventing tear out.
You're absolutely right. That's the throat plate or table insert. It covers the throat, which is the opening in the table saw's table or a router table, where the blade or bit protrudes. Standard throat plates have a fairly wide opening to accommodate tilting the blade.
But you can improve on that.
Definitely. For better results, especially with delicate cuts, thin materials, or when cutting plywood to minimize splintering, you can use a zero clearance insert.
Zero clearance.
Yeah. This is a special type of throat plate, often made from wood or phenolic resin, with no initial opening. You install it, turn the saw on, and carefully raise the spinning blade, or dado set, up through the insert, cutting its own perfect slot.
So the opening perfectly matches the blade.
Exactly. Because the opening perfectly matches the blade's cutting width at that specific angle, it provides maximum workpiece support right up to the edge of the cut. This significantly reduces chip out, where splinters break away from the workpiece, especially on the bottom edge of a crosscut. And it also prevents small, thin offcuts from dropping into the throat opening and potentially jamming the blade or getting thrown back. It's a simple, often shop-made accessory that makes a huge difference in cut quality and safety.
Moving beyond the table saw, what about routers? They have their own specific components that hold the cutting bits, right? And while we're on blades, what exactly is a dado blade or a dado set? Seems related to those grooves we talked about.
Routers absolutely do have their own critical parts. The collet is a vital component of any router.
Collet, right.
It's a metal slotted sleeve, usually tapered, that holds the router bit firmly and accurately in place in the router's output shaft or spindle. It's secured and tightened by a collet nut.
And they come in different sizes.
Yes. Most routers, especially plunge routers or more powerful fixed-base models, come with both 14-inch and 12-inch collets to accommodate the different shank sizes of available router bits. 12-inch shank bits are generally preferred for heavier cuts as they're more rigid and less prone to vibration or breaking. Some smaller, inexpensive trim routers might only have a 14-inch collet.
Are they interchangeable between brands?
Generally, no. It's important to be aware that collet styles and the nuts that tighten them vary significantly between brands and even models within a brand. They are typically not interchangeable. Always use the correct collet and nut for your specific router.
Okay. And dado blades.
Right, related to those grooves. A dado set is a specialized set of circular saw blades designed specifically for use on a table saw or radial arm saw. Its purpose is to cut wide, flat-bottom grooves or channels, dados or grooves, typically wider than a standard saw blade's curve, in a single pass.
How does it do that?
They usually consist of two thicker outside saw blades, similar to standard blades, but with flat-top teeth, and several thinner two-tooth chippers in between. By adding or removing chippers, and sometimes using thin shims, you can precisely adjust the total width of the cut to match plywood thicknesses or your desired groove width. They're essential for strong cabinet joinery.
And what does collet runout mean? That sounds like something you definitely want to minimize for accuracy with a router.
You're right to be concerned about it. Collet runout refers to the amount of deviation from the true center, essentially. Wobble in the router collet itself as it spins. It's measured in thousandths of an inch using a dial indicator.
And why is that bad?
Even a small amount of significant runout means the router bit isn't spinning perfectly true. This can lead to imprecise, inconsistent cuts, as the bit effectively cuts a slightly wider or uneven path than intended. It can also cause excessive vibration, lead to premature bit wear, chatter marks on the wood, and even increase the risk of bit breakage, shortening the life of your expensive router bits. Minimizing runout is key to precision work and bit longevity. Quality routers generally have lower runouts.
You mentioned kickback as a serious safety concern earlier with table saws. What are some other general safety devices or practices we should know about that are used across different machines to keep fingers safe?
Absolutely. Beyond the machine-specific guards, personal safety practices and aids are crucial. One of the most fundamental is the push stick.
Push stick. Simple but effective.
Incredibly simple, incredibly effective. This is typically a shop-made device, often just a notched piece of scrap wood, used to push a workpiece past a blade or bit during a machining operation, especially on a table saw or router table. Its sole purpose is to keep your hands safely away from the cutting area, especially when working with smaller pieces or making cuts close to the fence. Never use your hands directly for that final push near the blade.
Okay. What about push blocks?
A push block is similar in purpose, but usually offers more downward pressure. It typically has a handle on top and a non-slip bottom surface. It allows you to apply both downward pressure to keep the wood flat on the table and forward force when ripping stock on a table saw or feeding wood across a jointer. Sometimes they have a heel to catch the back edge of the board.
And feather boards. You mentioned those briefly.
Yes, another excellent device for both accuracy and safety is a feather board. This device, either shop-made from wood or commercially made from plastic, uses a series of narrow, flexible fingers cut at an angle.
Like feathers.
Kind of, yeah. These fingers apply steady, consistent pressure to hold a workpiece firmly against a machine's table surface, or, more commonly, against the fence during a cut on a table saw or router table.
How does that help safety?
It dramatically increases the accuracy of your cut by preventing the workpiece from drifting away from the fence. And it significantly improves safety by preventing the workpiece from moving unexpectedly, vibrating, or potentially being caught and kicked back by the blade or bit. It acts like an extra hand, holding the wood securely.
What about protecting the machines themselves from power fluctuations and preventing accidental restarts after a power outage? That sounds like a significant safety feature for larger tools, especially if you step away for a second.
Yes, especially for larger stationary machines like table saws, jointers, planers, or bandsaws. A magnetic starter or magnetic switch is a crucial safety device.
Magnetic starter, how does that work?
It's a type of power switch that provides overload protection for the motor and, critically, no-volt release protection. It contains contact points that are held closed by electromagnetic attraction when the switch is manually turned to the on position.
Okay.
If there's a power interruption, like a brief blackout, someone tripping over the cord, or a circuit breaker tripping, the electromagnetic attraction stops instantly, and a spring pulls the contacts apart, turning the switch definitively off.
So it doesn't just come back on when the power does.
Exactly. That's the key safety feature.
Yeah.
It prevents the machine from accidentally restarting when the electrical power returns, eliminating the huge risk of an unattended machine suddenly roaring back to life while you're not expecting it or have your hands near it.
That seems essential for big machines.
It really is standard on most larger industrial-style machines. For smaller benchtop tools, while a magnetic starter isn't always standard, alternative safety practices become even more important. Always unplugging tools when changing blades or bits, or when leaving the workshop, always being present and focused when a tool is running, and ensuring clear, immediate access to the power switch or an emergency stop button if one is fitted. And speaking of workshop safety, we can't forget dust collection.
Right, sawdust gets everywhere.
It does, and it's more than just messy. It's a vital but often overlooked aspect of workshop health and safety. A good dust collection system uses ducts connected to machines and a powerful vacuum or collector unit to remove sawdust and wood chips from the air and from hewn surfaces. This drastically improves air quality, reducing respiratory risks, improves visibility while working, and significantly reduces fire hazards, as fine dust can be highly flammable.
Now that we've covered the machines and safety, let's get into the actual cuts we make in woodworking. What's the fundamental difference between a rip and a crosscut? These sound like basic cuts, but I imagine getting them right is foundational.
They are indeed basic, but absolutely critical to understand, as they dictate how you orient the wood relative to the grain and often what tools or blades you use for the best results. A rip cut, or ripping, is a cut made parallel to the direction of the wood grain.
Along the grain.
Exactly. Typically used for narrowing boards or cutting long strips from a wide oak board. Think about taking a wide board and making it thinner lengthwise on a table saw using the rip fence.
Okay. And crosscut.
A crosscut is, as the name suggests, a cut made across the wood grain, usually perpendicular to it. This is often done for shortening boards to length or squaring up the ends. You typically use a miter saw or a table saw with a miter gauge or crosscut sled for this.
Different blades for each.
Often, yes. Rip blades have fewer teeth with a more aggressive hook angle, designed for efficiently removing material along the grain. Crosscut blades have more teeth with alternate top bevels, ATB, designed for shearing the wood fibers cleanly across the grain with less tear out. Combination blades try to do both reasonably well. Understanding which cut you're making helps you choose the right blade for efficiency, cut quality, and safety.
And resawing, that sounds a bit more specialized than just cutting across with the grain.
Resawing is a specialized cut, but a very useful one. It's where you slice a length of wood with the blade running parallel to the workpiece's faces, effectively creating thinner pieces from a thicker board.
So splitting a thick board into thinner ones.
Exactly. If you have a 44 1-inch thick board and you want two approximately 12-inch thick boards, maybe for making your own veneers, book-matching panels for a beautiful symmetrical grain pattern, or just getting thinner stock, you would resaw it.
What tool do you use?
It's usually done on a table saw with a tall auxiliary fence for support, but more commonly, and generally more effectively and safely, it's done on a bandsaw. The thinner blade of a bandsaw reduces waste by creating a much narrower kerf, and bandsaws typically have a much greater cutting height capacity than table saws. It's a great way to maximize your expensive lumber or create unique matched panels where the grain flows across the joint.
Beyond basic cuts, we have channels and edges that are cut into the wood, often for joinery or sometimes just for aesthetics. What's a dado, a groove, and a rabbet? They all sound like ways to fit pieces together.
They are, and they're fundamental joinery cuts. Each has a specific orientation and application. A dado is a square-cornered channel or trench cut across the wood grain.
Across the grain, like for shelves.
Exactly. It's commonly made with that dado set we talked about on a table saw, or with a straight router bit guided by a jig. Dados are perfect for supporting shelves, where the edge of a shelf fits snugly into the channel cut across the side of a cabinet, providing very strong vertical support.
Okay. And a groove.
A groove is very similar. It's also a square-cornered channel, but it's cut parallel to the wood grain.
Along the grain this time.
Right. Grooves are often used for things like capturing drawer bottoms within the sides of a drawer box, or for holding the panel inserts in frame and panel construction like cabinet doors.
And a rabbet. That sounds different.
A rabbet is an L-shaped channel, or recess, cut along the edge or end of a workpiece. It's like cutting a step into the edge.
An L shape, okay.
Rabbets are frequently used for fitting backs into cabinets. The back panel sits in a rabbet, cut around the inside edge of the cabinet sides and top bottom. They're also used for joining two pieces at a corner to create a strong, overlapping joint, like in box construction, or for creating a lip for a glass panel and picture frame. They're all about creating an interlocking fit for strength and alignment.
And for softening the sharp edges of a piece of wood, what are the terms for that? Because a sharp 90-degree edge can chip easily or just feel uncomfortable to handle.
Right. Easing edges is important for both durability and feel. You have a couple of common options depending on the aesthetic you're after. You can chamfer an edge.
Chamfer.
That means beveling the edge at an angle, usually 45 degrees, creating a distinct flat surface on the corner instead of a sharp point. It gives a clean, geometric look.
Okay.
Or you can ease an edge, which is a more general term, meaning slightly relieving or softening a sharp edge. This is generally accomplished by lightly sanding it down with sandpaper, taking a very light pass with a block plane, or, very commonly, rounding it over slightly with a small 18-inch or 14-inch round-over router bit. The goal is simply to make the edge less prone to chipping and more pleasant to touch, less sharp.
And for plywood edges.
Yes. When working with sheet goods like plywood or MDF, which have exposed, sometimes unattractive layered or processed edges, you might add edging or edge banding.
To cover the ugly edge.
Exactly. This is typically a strip of solid wood, usually 14-inch thick or maybe more, that's glued onto the bare edge of the plywood panel. It's then trimmed flush with the top and bottom surfaces, often using a flush trim router bit. This hides the core layers and gives the appearance of solid wood. Plus, it provides a more durable edge. You can also use thin veneer edge banding, often iron-on, for a quicker but less durable solution.
When we're drilling holes for screws, it seems there's more to it than just grabbing any old drill bit. What are pilot holes, shank holes, counter bores, and countersinks? These all sound like specific types of preparatory holes for screws.
They are, and using the right combination is absolutely key to strong, clean joinery when using screws, preventing wood splitting, and ensuring the screw does its job properly. Let's start with a pilot hole.
Pilot hole?
This is a hole drilled primarily in the piece of wood that will receive the threaded portion of the screw. It should be just slightly smaller than the screw's root diameter, the diameter not including the threads. This allows the screw threads to bite firmly into the wood, providing maximum holding power without splitting the wood, especially near edges or ends.
Okay, smaller than the screw threads. What's a shank hole?
A shank hole, sometimes called a clearance hole, is drilled in the top piece of wood the piece the screw passes through first. It's drilled to receive the unthreaded portion of a wood screw shank right below the head. This hole should be slightly larger than the shank diameter.
Why larger?
This is crucial. It allows the screw shank to pass freely through the top piece without its threads engaging in that piece. This ensures that when you drive the screw, it pulls the two pieces tightly together, creating a strong clamping action. If the screw threads engage in both pieces, you can actually hold them slightly apart.
Ah, okay. Pilot hole for the threads, shank hole for the shank. Got it. Now, what about hiding screw heads or making them sit perfectly flush with the surface for a clean look?
Right, you don't always want screw heads visible. For completely hiding a screw head, you use a counterbore.
Counterbore.
This is a shallow, flat-bottomed hole drilled before the shank hole that's wide enough to accommodate the entire screw head and allows you to set it below the surface of the wood. It's a stopped hole, meaning it doesn't go all the way through the material. After driving the screw, you can then glue in a matching wood plug or use wood filler to completely conceal the screw head for a seamless finish.
Okay, that's for hiding it. What if I just want it flush?
If you just want the screw head to sit flush with the surface, especially when using flathead screws which have a tapered underside, you use a countersink.
Countersink.
This is a shallow, conical-shaped hole drilled at the top of the shank hole that perfectly matches the angled shape of a flathead screw head. This allows the tapered head of the screw to sit perfectly flush with, or slightly below, the surrounding wood surface, preventing it from protruding and catching on things or looking messy. Special countersink drill bits create this shape.
And for specific types of holes that are a bit more unusual, like flat-bottomed holes for hinges or maybe perfectly centered pilot holes for hinge screws.
Good examples. For drilling clean, precise, flat-bottomed holes that don't penetrate all the way through the wood, essential for installing certain types of hardware, like European cabinet hinges, which need a large, shallow hole, or for shelf pins, you use a Forstner bit.
Forstner bit.
Right. It's designed specifically to bore very clean, flat-bottomed holes with smooth sides and a clean circumference, unlike a standard twist drill, which leaves a pointed bottom. And for getting those perfectly centered pilot holes, especially crucial for hinge-mounting screws, where even slight misalignment looks terrible and can cause binding.
Yeah, getting those tiny hinge screws centered is tricky.
It is. For that, there's a brilliant little gadget called a self-centering bit, often popularly called a VIX bit, after a well-known brand.
VIX bit, okay.
It uses a standard twist drill bit housed inside a retractable, spring-loaded outer sleeve with a tapered nose. The tapered end of the sleeve fits perfectly into the countersink on a hinge screw hole or other hardware. When you press the tool down, the sleeve retracts and automatically centers the internal drill bit perfectly in the hole, ensuring your pilot holes, and thus your screws, are always dead center. They're fantastic for hardware installation.
That sounds useful. Any other special holes?
One more common one, especially in fast cabinet construction or face frame assembly, is a screw pocket or pocket hole.
Pocket holes. I've seen jigs for those.
Exactly. A screw pocket is a hole drilled at a specific low angle, usually around 15 degrees, into a board or piece of sheet goods. This allows a screw to be driven through that pocket into an adjoining piece, often from an unseen angle, like the inside of a cabinet or the back of a face frame. It provides a strong, fast connection without visible fasteners on the primary show surface. Specialized jigs, like those made by Craig, make drilling these angled holes accurately very easy.
Rotors have some specific operations too, beyond just cutting decorative profiles or using those Forstner bits. What's a climb cut, and what are flush trim or slotting cutters?
Yeah.
And what about classic joinery techniques that involve precise cuts?
Right, routers are incredibly versatile.
Right.
Let's talk about climb cutting first because it requires caution.
Okay, sounds risky.
It can be. A climb cut is a routing operation where the router is moved in the same direction as the bit's rotation, rather than against it, which is the normal, standard, and safer method called conventional cutting.
Why would you do it?
The result can sometimes be a cleaner cut, especially in figured wood or woods prone to tear out, because the bit slices into the wood rather than scooping out of it. However, it's significantly harder to control. The router tends to want to climb along the workpiece, pulling itself forward aggressively. For this reason, if you ever attempt it, you should always make very, very light cuts and maintain a very firm grip and control. It's generally best left to highly experienced professionals or approached with extreme caution and awareness of the increased risk.
Good to know. What about flush trim bits?
A flush trim router bit is incredibly useful. It's essentially a straight cutting bit but with a ball bearing mounted either at the tip or sometimes at the base of the cutter near the shank. This bearing rides along a template or the edge of a substrate.
So it follows a pattern.
Exactly. Its typical use is for trimming overhanging edges of workpieces, whether it's solid wood edging, plastic laminate on a countertop, or trimming a piece to match a template perfectly, leaving the edge perfectly flush and smooth with the surface the bearing followed. They're essential for template routing and trimming edge banding.
And slotting cutters?
A slotting cutter is a specific type of router bit designed specifically to cut narrow grooves or slots into the edges of boards. They usually consist of an arbor and interchangeable cutters of different thicknesses.
What are they used for?
These grooves are commonly used for spline joint assembly. A thin strip of wood or manufactured material, a spline, is inserted into matching slots cut in the edges of two pieces being joined edge to edge or end to edge. This provides a strong, hidden joint that adds significant glue surface area and alignment strength, often used in frame and panel construction or joining boards.
Okay. And classic joinery, like dovetails.
Right, beyond basic cuts, we get into traditional joinery methods that rely on precise cutting for both strength and aesthetics. A mortise and tenon joint is a cornerstone of furniture making. It involves cutting a rectangular hole or recess, the mortise, into one piece of wood, and a corresponding projecting tongue, the tenon, on the end of another piece, which then fits snugly into the mortise. It creates a very strong mechanical lock, especially for right-angle joints like table legs to aprons.
And dovetails, they look fancy.
Dovetails are iconic for a reason. They're an interlocking joint known for their exceptional mechanical strength, especially against pulling forces, and their beautiful appearance, often showcased on drawer boxes or fine casework. The joint consists of a series of trapezoidal pins cut on the end of one board, fitting tightly into corresponding flared tails cut on the end of another board. Cutting them accurately by hand is a mark of skill, but jigs exist for routers too.
Any others?
Another common one is a finger joint, sometimes called a box joint. It's a series of interlocking rectangular fingers cut into the ends of two boards that fit together perfectly, like interlaced fingers. It creates a very strong joint with a huge amount of glue surface area, often used for making boxes, drawers, or joining pieces end to end for length. You might also simply cut a bevel, which is an angled cut on the edge or sometimes the face of a board, producing a sloped surface rather than a sharp 90-degree corner. This can be decorative or part of a miter joint.
That's a huge amount of detail on the actual cutting and joining. Before we even pick up a saw, though, planning is key to any successful woodworking project. What are materials lists and cutting diagrams? They sound like blueprints for efficiency and avoiding costly mistakes.
They absolutely are essential tools for planning, minimizing waste, and just generally staying organized, which directly impacts your budget and efficiency, not to mention your sanity. A materials list, sometimes called a bill of materials or cut list, is a detailed chart that typically accompanies a woodworking project plan.
That's on it.
It breaks down every single part of your project, usually assigning each part a letter or name. It lists its final, precise dimensions, thickness, width, length, the specific material it should be made from, like cherry or 34 plywood, and the quantity needed for each part. It might even include special notes like grain direction requirements or mentioning which edges get edge banding. This list is your guide for purchasing lumber and preparing your stock accurately, ensuring you don't forget anything or cut something the wrong size.
Okay, that makes sense. And a cutting diagram.
A cutting diagram is usually an illustrated guide that shows you the approximate quantities and sizes of the rough boards or sheet goods required for a project. Crucially, it shows how each individual part from your materials list should be laid out efficiently on your rough stock to minimize waste. It helps you visualize how to break down larger boards or sheets into the smaller pieces you need.
So it saves wood and money.
Ideally, yes. However, it's really important to remember that cutting diagrams are guidelines only, especially when working with solid wood. They can account for unique grain variations you might want to feature or unexpected defects like knots, checks, or sapwood that you need to cut around in your actual boards. So you use the diagram as a starting point for planning, but always inspect your real material and adjust the layout accordingly before making cuts.
And sometimes we need to make rough cuts first before getting to the final dimensions listed on the materials list, right? What's the strategy behind that?
Exactly. That process is called rough cutting. To rough cut a workpiece means to cut it slightly oversized compared to its final dimensions. maybe adding 12-inch to the length and width, and perhaps leaving it a bit thicker if you're milling rough lumber.
Why do that? Why not cut to final size right away?
There are a few reasons. First, it gives you a little extra material to work with to account for any minor milling errors during subsequent steps like jointing and planing. Second, wood can sometimes move or warp slightly after initial cuts as internal stresses are released, so leaving it oversized gives you material to flatten and straighten again. Third, it allows you to get pieces to a manageable size before focusing on bringing them down to their precise final dimensions. It's about giving yourself a buffer for achieving accuracy in the final steps.
What about those clever little helpers and general shop materials we might encounter, like special hammers or clamps, or even just basic shop organization aids? It seems like there's a tool for everything.
There really are many indispensable aids, big and small, that make woodworking easier, more precise, and safer. You mentioned hammers. A specialized one is a burnisher.
Burnisher. What's that for?
It's typically a hardened steel rod, sometimes round or triangular in cross-section, with a handle. Its specific purpose is to create the tiny hooked cutting edge or burr on a cabinet scraper. A cabinet scraper is a thin sheet of steel used for smoothing wood, and it cuts using that burnished hook. Honing that edge properly is key to making the scraper work effectively.
Okay. And a dead blow hammer.
A dead blow hammer is a fantastic tool for assembly or persuasion without damage. It typically has a plastic or rubber head that's hollow and partially filled with steel shot or sand.
Shot inside. Why?
When you strike an object, this shifting mass of shot moves forward and absorbs the impact energy, preventing the hammerhead from bouncing or rebounding. This delivers a solid, controlled blow with maximum force transfer, but minimizes the risk of marring the workpiece surface. It's ideal for tapping joints together during assembly, disassembling tight fits, or setting things in place without denting the wood.
And those classic wooden clamps you see in old workshops, the ones with 2 wooden jaws and 2 screw handles, what are those called? And what about those common sheet materials we often use for jigs or shop organization, like pegboard?
The wooden clamps are called hand screws. They're traditional, incredibly versatile clamps consisting of 2 long, parallel wooden jaws, often maple, joined by 2 independently threaded rods with handles.
Why 2 screws?
Because you can adjust each screw independently, you can position the jaws parallel to one another for standard clamping, or you can angle them to clamp tapered or irregular shapes that would be impossible with irregular clamps. They come in various sizes based on jaw length, typically from 4 inches up to 12 inches or more. The throat depth, which is how far into the jaws you can reach, is typically about half of the jaw length. They provide great pressure over a wide area.
Cool. And the sheet material.
You're likely thinking of hardboard. This is a very common and inexpensive engineered wood product. It's made from finely ground wood pulp mixed with resins and then pressed under heat and pressure into large 4 by 8 foot sheets, typically 18-inch or 14-inch thick. It often goes by the brand name Masonite, as that was one of the original manufacturers.
What's he used for?
Lots of things in the shop: drawer bottoms, cabinet backs, templates, jig bases. For shop use, the slightly darker, harder service-tempered grade is usually best for its durability. And a common variation you mentioned is perforated hardboard, universally known as pegboard, though that's technically a brand name. It's usually 14-inch thick hardboard with rows of pre-drill holes at regular intervals, perfect for organizing tools on a wall using various metal hooks and hangers.
And what about the concept of a jig itself? It seems like it's a broad term for something custom-made, but incredibly vital for consistent results.
A jig is indeed a fundamental concept, maybe the fundamental concept for efficiency and accuracy in woodworking. Broadly, it's any device that holds a workpiece or guides a tool so that a specific task can be performed efficiently, accurately, safely, and repeatedly.
So it helps you do the same thing over and over correctly.
Exactly. Jigs are very often shop-made, custom-built by the woodworker for a specific, repetitive task for a particular project. They are incredibly versatile and range from simple to complex. They allow for levels of precision and repeatability that would be difficult, time-consuming, or sometimes impossible to achieve by hand measurement alone.
Can you give an example of a simple jig?
Sure. A very simple but essential jig is a length stop or stop block. This is often just a block of wood clamped firmly in place on a miter saw fence or a table saw crosscut sled. It serves as a fixed reference point. When you crosscut multiple pieces to the exact same length, you just butt the end of each workpiece against the stop block before making the cut. Every piece comes out identical. A stop block can also be attached to a workpiece to limit the travel or depth of cut of a tool, like a router, ensuring a consistent depth or stopping a cut at a precise point.
Any other handy shop aids?
Oh, tons. Cawls are useful during glue-ups. They're strips of wood, usually perfectly straight but sometimes curved, that are placed across a panel or assembly underneath the clamps. They help distribute the clamping pressure evenly over a wider area, preventing the clamps from digging in and denting the wood and helping to ensure flat glue-ups for panels. And bench dogs are small, usually cylindrical or rectangular pegs made of wood, metal, or plastic that fit snugly into holes drilled in the top of a workbench. They work in conjunction with a vise or other dogs to hold workpieces securely in place on the benchtop for operations like hand planing, sanding, or carving.
What if you have a board that doesn't have a straight edge to begin with? Like maybe it came rough sawn or one edge is wavy. How do you get that initial straight line so you can then cut it accurately parallel on the table saw using the fence?
That's a common problem when working with rough lumber. The solution is straight line ripping. It's a process specifically for truing or straightening one edge of a board that has no reliable straight edge to reference against the table saw fence.
How do you do it?
There are a few ways. One common method is to attach a known straight edge piece of material, maybe a factory edge from a sheet of plywood, or a long level, or a special straight edge jig along the length of your workpiece, perhaps holding it with clamps or double-sided tape. Then, you run that known straight edge against the saw's rip fence, allowing the blade to cut a perfectly straight edge on your irregular board, parallel to the guide. It's an essential first step for squaring up rough lumber before you can reliably use the fence for further cuts.
And for marking lines accurately, pencils aren't always precise.
You're right, pencil lines can be fuzzy. For ultimate precision, especially when laying out joinery, many woodworkers use a marking knife. It's a small, sharp knife, often with a bevel on only one side, used to score a fine, crisp line into the wood surface. This line is much more precise than a pencil line, gives a definitive edge to measure from or cut to, and it also helps prevent tear-out when making a crosscut by pre-severing the surface fibers.
And to get those consistent thicknesses for multiple boards, or to reduce a board's thickness from, say, a rough sawn piece down to a usable dimension.
For that, the key machine is a thickness planer, sometimes just called a planer. Note that it doesn't make edges straight or square. That's the jointer's job. A planer makes the top face of a board parallel to the bottom face and reduces its overall thickness.
How does it work?
It uses a horizontal rotating cutter head equipped with sharp knives, or sometimes segmented carbide cutters, housed above the machine's bed. As the stock is fed through the machine by powered in-feed and out-feed rollers, the cutter head rotates at high speed and shaves wood from the top face of the board as it passes beneath. The cutter head assembly and rollers can be adjusted up and down to precisely control the final thickness and the depth of cut per pass.
They come in different sizes.
Yes. Larger stationary thickness planers found in professional shops usually have a 15-inch or even wider capacity. Portable benchtop models, very popular in home shops, typically handle boards up to 12 or 13 inches wide. A planer is essential for milling rough lumber down to consistent, usable thicknesses for matched panels or precise joinery.
Any other simple shop aids?
One more simple but useful one for drilling, a V-block. It's often just a square block of wood, typically shop-made, with a precise V-shaped groove cut along the length of one face. It's indispensable for securely holding dowels, pipes, or other round or cylindrical objects steady on a drill press table or workbench, preventing them from rolling while you drill accurate holes through them. And to keep track of critical measurements for a project without constantly remeasuring, many woodworkers use a story stick. It's simply a piece of wood or strip of material with all the critical dimensions and layouts of a project marked directly onto it. You use it as a direct physical reference to transfer measurements, reducing the chance of cumulative errors from using a tape measure repeatedly. And for checking if a board is twisted, you can use winding sticks. These are just two perfectly straight, identical sticks. You place one across each end of the board and set across their top edges. If the tops line up perfectly, the board is flat. If one side of the far stick appears higher than the other, the board has twist or wind.
So we've covered the raw material, the glues, the tools, and the cuts. Now let's transition to the terms specific to building larger structures like furniture and cabinets. What's the difference between an apron and a stretcher on a table or chair? They both seem to connect legs, but I gather it's about their placement.
They're both horizontal structural pieces that connect the legs of a table or chair, adding rigidity. But yes, their placement and primary function differ slightly. An apron is a horizontal piece, or set of pieces forming a frame, that typically supports the underside of a tabletop or a chair seat and connects the upper portions of the legs right below the top or seat.
So up high?
Right. It adds structural integrity, helps distribute the weight of the top or the sitter, and prevents the legs from splaying outwards. A stretcher, on the other hand, is also a horizontal piece that connects the legs, but it's typically found connecting the lower portions of the legs on a table or chair base.
Down low near the floor.
Often, yes. Stretchers primarily add stability, preventing the legs from wobbling or racking, and often contribute significantly to the overall design aesthetic, especially in traditional furniture styles like Windsor chairs or trestle tables. You can have multiple stretchers connecting front-to-back legs and side-to-side legs.
Okay. Apron high, stretcher low. Got it. And within a cabinet itself, what terms define its basic structure or how its doors and drawers fit into that structure?
The core structure, the box itself, is generally called the cabinet carcass, or carcass. This is the main box-like component that forms the body of the cabinet, and it's then fitted with internal components like drawers, shelves, and body doors. It's the foundational box, usually made of solid wood or sheet goods like plywood or MDF.
And the layers in plywood.
Right. When we talk about sheet goods like plywood, the internal layers sandwiched between the outer face and back veneers are collectively called the core. These layers make up the bulk of the sheet's thickness and provide its structural integrity and stability. The core might be made of softwood veneers, particle board, or MDF, depending on the type of plywood.
Okay. What about drawer fronts? Sometimes they look separate from the drawer box.
Good observation. You'll often see a false front used on a drawer. This is a non-structural decorative face panel that is applied to the front of the actual structural drawer box assembly. It provides the finished, visible surface that you see from the outside.
Why do that instead of making the front part of the box?
What's particularly clever and useful about using a false front is that because it's separate from the main drawer box, you can precisely adjust its position, up, down, left, right, during final assembly to get the best, most even gaps and alignment within the drawer opening in the cabinet. You can do this without needing to reposition the drawer slides or rebuild the drawer box itself. It's a very common technique for achieving perfectly aligned drawer banks, especially with overlay styles.
That makes sense. What about divisions inside a cabinet?
When you open a cabinet, particularly a base cabinet with drawers, you might see a web frame. This is a structural frame, often made of solid wood strips, that forms the horizontal divisions between drawers, or between a drawer and a lower cabinet opening. It adds rigidity to the carcass and usually provides a mounting surface for the drawer slides.
And that notch at the bottom of kitchen cabinets?
Ah, yes, that recessed area at the very bottom front of a base cabinet, especially in kitchens or vanities. It's called a toe pick. It's typically set back 3 to 4 inches from the front of the cabinet and is maybe 4 inches high. It's designed for comfort. It provides space for your toes so you can stand closer to the countertop without kicking the cabinet door or front.
And what about how cabinet doors or drawer fronts actually fit into the opening? Or those dividing pieces within a cabinet frame or a door, like the vertical and horizontal bars?
Right, how the doors and drawers relate to the cabinet opening defines the style. This brings us to overlay and inset styles. An overlay door or drawer front sits on top of the cabinet opening, covering or overlaying a portion or all of the cabinet face frame or the edge of the carcass if it's frameless.
Covering the edge.
Exactly. There are different types like full overlay, where the door covers almost all of the face frame, leaving very minimal reveal, or partial overlay, where the door covers only part of the frame, leaving a noticeable gap or reveal around it. In contrast, an inset door or drawer front sits within the cabinet opening, perfectly flush with the face frame or the side of the cabinet box.
Flush inside the opening.
Right. This provides a very clean, traditional, often high-end look, but it requires much greater precision during construction and installation, because any inconsistencies in the opening or the door size are immediately obvious. The small, consistent gap around an inset door or drawer where it meets the frame is called the reveal. Getting those reveals perfect is key to the inset look.
Okay. And the dividers within frames.
Within a cabinet frame or a door frame, you'll often find mullions or muntins. These are intermediate vertical or horizontal members within a larger frame that form divisions between separate units, such as individual panes of glass in a door or decorative panels. Within a classic frame and panel construction, which is ubiquitous in cabinet doors and furniture,
Frame and panel, right.
you have rails, which are the horizontal members of the frame. They typically run between 2 vertical pieces. Those vertical pieces of the frame are called stiles. So you build a rectangular frame using horizontal rails, top and bottom, maybe intermediate ones, and vertical stiles. This frame usually has a groove on the inside edge to capture a floating panel, which can be solid wood or plywood. This construction method allows the panel to expand and contract with humidity changes without stressing the frame joints.
And the things drawers slide on.
Simple but essential. Those are drawer slides or drawer runners. This is the hardware, usually metal, that allows drawers to slide smoothly in and out of the cabinet carcass. They come in various types, including traditional wooden runners, simple side-mount epoxy-coated slides, more robust ball-bearing side-mount slides, and increasingly popular undermount slides, which are concealed beneath the drawer box for a cleaner look. Each type has different weight capacities, extension lengths, how far the drawer pulls out, and features like soft close mechanisms.
After all that cutting, shaping, and joining, we finally reach the finishing line. This is where the true beauty of the wood really comes out and where your project gets its protection from wear and tear. What does it mean to hone an edge, and what are penetrating finishes?
Right, finishing is crucial. But even before finishing, tool sharpness is key. To hone means to polish and refine a cutting edge, typically after initial sharpening on coarser stones. You rub the edge against a very hard, smooth surface like a fine water stone, oil stone, ceramic stone, or even leather strop charged with polishing compound.
Why hone? Isn't sharpening enough?
Honing removes the microscopic scratches left by sharpening stones and creates a razor-sharp, highly polished edge. This is absolutely crucial for getting the best performance from chisels, plane blades, and carving tools. A truly honed edge allows for cleaner, easier cuts with less effort and results in a smoother wood surface, often reducing the need for sanding. A sharp honed tool is a safe, efficient, and satisfying tool to use.
Okay. Now finishes. What's a penetrating finish?
When it comes to wood finishes, a penetrating finish is a type that, as the name suggests, soaks into the wood pores rather than building up a distinct film or layer on top of the surface. It resides mostly within the wood itself.
Oil finishes.
Exactly. Common examples include tung oil, boiled linseed oil, BLO, and various products often labeled as Danish oil, which are typically a blend of oil, varnish, and thinners. These finishes work by hardening within the wood fibers, enhancing the natural color and grain, popping the grain, and providing some water resistance. They generally offer a more natural, close-to-the-wood look and feel, and they're often very easy to apply, just wipe on, wipe off, and relatively easy to repair if they get scratched. You can also just wipe on a bit more oil. However, they typically offer less protection against abrasion and liquids than film finishes.
And for sanding and smoothing surfaces, especially between coats of finish when you get those little dust nibs, are there alternatives to traditional sandpaper? And what are some of the common film building finishes that do sit on top?
Yes, for smoothing between coats of finish or for rubbing out a final finish to adjust its sheen, many woodworkers widely use synthetic steel wool. You probably know it by the brand name Scotch-Brite pads.
Yeah, the green or gray scrubbing pads.
Exactly, though they come in various colors indicating different grits. These are flexible, non-woven abrasive pads made from thin plastic fibers like nylon, impregnated with abrasive particles like aluminum oxide or silicon carbide. They're compressed together in a random pattern.
Why use them instead of steel wool?
They're exceptionally useful for sanding woodworking projects, especially contoured shapes, because they can form easily. They're great for scuff sanding between coats of finish to improve adhesion and remove minor imperfections like dust nibs without leaving behind the tiny metal particles that traditional steel wool can, which might rust. They come in various grits that roughly correspond to sandpaper grits or steel wool numbers like fine, very fine, extra fine, giving you a range of abrasive options.
Okay. And film finishes, the ones that build a layer.
Right, for more protection, you use a film finish. Polyurethane is probably the most popular choice for general woodworking today, especially oil-based poly for durability. It's essentially a plastic coating, a synthetic varnish that cures to a hard, durable film. It comes in oil-based formulas, more durable, amber tint, slower drying, solvent cleanup, or water-based formulas, dries clear, faster drying, less odor, water cleanup, perhaps slightly less durable. It offers good protection against moisture, scratches, and abrasion.
What about lacquer?
Lacquer, specifically nitrocellulose or acrylic lacquer, is another major film building finish, especially favored in production furniture settings. Its main advantage is that it dries extremely quickly, often just minutes between coats, allowing for a finish to be built up rapidly. It typically melts into the previous coat, creating a single homogeneous film. It produces a very smooth, hard surface and can be rubbed out to a high gloss. It's often sprayed on for the best results, and traditional nitrocellulose lacquer can amber over time.
And shellac. That sounds old-fashioned.
Shellac is actually a fantastic finish, derived from a natural resin secreted by the lac beetle. It's dissolved in denatured alcohol, to make liquid shellac.
From a beetle, wow.
Yeah. It's very easy to apply, often wiped or brushed with a technique called French polishing, dries incredibly quickly, and is an excellent sealer for wood, particularly good at blocking knots or oily resins before applying other top coats. It adheres well to almost anything, and almost anything adheres well to it. Plus, like hide glue, it's reversible with alcohol, making it easy to repair, though it's not very resistant to water or alcohol itself. It gives a warm, classic look.
So many choices. Any other finishing terms?
A couple more common ones. Before applying a clear finish, you might use a stain. This is a coloring agent, either pigment-based, particles sitting in the pores, or dye-based, dissolving into the wood fibers, applied to wood to change its color, while ideally still allowing the natural grain pattern to show through. And for woods with very large open pores, like red oak or mahogany, a grain filler or pore filler might be used before the top coat.
To fill the pores.
Yeah. Exactly. It's a paste-like product, often silica-based, that's worked into the open pores and then sanded smooth after drying. Its purpose is to fill the open pores completely, resulting in a perfectly smooth, level surface for the subsequent film finish, achieving that glass-smooth look you see on fine furniture. After a film finish like varnish or lacquer is fully cured, which can take days or weeks, some woodworkers choose to rub out the finish.
Rub it out.
Yeah, it's a meticulous process of progressively sanding the hardened finish with very fine abrasives, like 600 grit up to 2000 grit sandpaper, and lubricants, like mineral spirits or soapy water, followed by polishing compounds on a cloth pad. The goal is to remove any minor imperfections, dust nibs, orange peel from spraying, and achieve a perfectly smooth, uniform sheen, ranging from a soft satin to a deep, high gloss, depending on how far you take the process. Finally, a popular, easy-to-apply option is wiping varnish. This isn't really a distinct type of finish, but rather standard varnish, oil-based usually, that has been thinned significantly with mineral spirits. This allows it to be easily wiped onto the surface with a rag, much like an oil finish, minimizing brush strokes and drips. It builds a protective film more slowly than full-strength varnish, but creates a durable, beautiful hand-rubbed look with multiple thin coats.
And there you have it. Wow. From the nuanced botanical characteristics of a board to the precise functions of table saw components and the secrets of glues and finishes, we've taken a really deep dive into the fascinating lexicon of woodworking.
We certainly have.
You've now got the vocabulary to understand the craft on a whole new level, to spot critical safety features when you see someone working, and even to appreciate the hidden work and, well, the science that goes into a beautifully finished piece.
And by understanding these terms, you're not just learning definitions, you're gaining real insight into the processes, the challenges wood presents, and the ingenious solutions that woodworkers have developed over centuries to work with it effectively.
Yeah.
Knowledge is always most valuable when it's understood and can be applied, and hopefully this deep dive has given you a robust foundation to better appreciate, or maybe even engage with, this incredible hands-on craft.
So what does this all mean for you listening right now?
Well, you're no longer just looking at a piece of furniture. You may be seeing the apron, the styles, noticing if it's quarter-sawn oak, thinking about the kiln-dried lumber it started as, and maybe imagining the biscuits or mortise and tenons holding it all together internally. You might think about the safety features, like the riving knife or the anti-kickback pawls that kept the maker safe. Or maybe the open time of the glue they were racing against as they clamped up a complex joint.
Right. You might even spot the subtle beauty of that quarter-sawn grain we talked about, or a unique burl figure, and understand why it's special. This deep dive has truly given you, I hope, a new lens to view the world of wood and the artistry involved in shaping it.
And this raises an important question, maybe something for you to consider. What seemingly simple craft or hobby, perhaps one you already enjoy or have always been curious about, maybe cooking or sewing or gardening, holds its own hidden lexicon, its own set of specialized terms that, once understood, unlock a whole new level of appreciation and capability? What's your next deep dive?
That's a great thought. Thanks for joining us for this deep dive into the world of woodworking terms. Until next time, keep learning, keep exploring, and keep those aha moments coming.